the most famous comet ever, Dr. Thomas Bopp.
This image that you're looking at is titled Sunset over the Pacific. It was taken by a friend of mine, astronaut Ed Liu, on the 21st of July 2003 from the ISS on Mission 7. What I especially like about it is, if you notice, the tops of the thunderheads down here, all illuminated by the sun. Unfortunately, due to the lighting here, you can't really see all that detail, but it's especially beautiful. Many thanks to Shannon Side Astronomy Club for sponsoring my presentation, and to Frank Ryan Jr. for all of his hard work and all the others that have worked so hard to make it possible. Today I'm going to share with you some images that will let you enjoy the excitement amateur astronomers experience every time they gaze at the sky on a dark, clear night. Then I'll tell you the somewhat humorous story of the discovery of the Hale-Bopp comet. I'll begin by introducing the man responsible for my early interest in astronomy, which resulted in a lifelong obsession and passion for the beauty of the heavens. This is my father, Frank Bopp. The telescope my father's holding was built by Thomas Cook and Sons in London, England in 1870, and we restored it for a friend of mine in 2001. My father had to make many parts for this telescope because the focuser and all the internal focusing parts were all lost in the move. My love for the sky began at a very early age. In his book, More Things in Heaven and Earth, astronomer and author David Levy sums up my beginning interest in the sky in the chapter, Choose Something Like a Star. To paraphrase him, imagine a comet wandering through space like an ancient sailing ship, rounding the sun every few 100,000 years, and after a near miss with the planet Jupiter, changes its path and visits the sun more frequently. I'm sorry, this mouse is really difficult to control. Eventually, the comet's elliptical journey is shortened so greatly that it now orbits the sun on a regular basis. On each visit, tiny particles escape from the comet and sometimes cross the Earth's orbit, producing brief flash of light, which are the meteors that we see sometimes on good dark evenings. One of the earliest things I looked at, my parents gave me a telescope for my 10th birthday. It was my first telescope. And then one of the earliest things I remember looking at was the double star Albireo. Very, very beautiful star. It's 380 light years distance. The two bright stars of Albireo are comparatively far from each other and take about 75,000 years to complete a single orbit. The next object I remember looking at was the Great Andromeda Galaxy, M31. This image is by an amateur. His name is Jerry Rodriguez. The galaxy is 220,000 light years in diameter, and it's more than twice the diameter of the Milky Way galaxy. You might not know it, but by looking just at the right place in a dark sky night from midsummer to early winter, you can see an object 2.9 million light years away. That's over 1,740,000,000,000,000 miles. The number 174 followed by 13 zeros. The Andromeda Galaxy is the most distant object visible to the naked eye. It appears as a cloudy smudge just above the constellation Andromeda. The light from 1,000,000,000,000 stars races through space at 186,282.397 miles per second. It takes over 1,000 centuries for the light from the far side of the galaxy just across the galaxy to begin its trip to us. This is the western hemisphere of this amazingly beautiful planet that we live on. And this is the eastern hemisphere. A lot of the images that I'm going to show you today are taken with the Hubble telescope. The Hubble Space Telescope was launched in 1990, although it was originally scheduled to launch in 1986 on the ill-fated Shuttle Challenger. It weighs 25,000 pounds and orbits at just over 368 miles in altitude. The telescope's 43 feet, 4 inches long, and 14 feet in diameter, and the mirror measures 2.4 meters, or just under 8 feet in diameter. This image is called the Hubble Deep Field. It's a 10-day exposure in an area the size of a grain of sand near the cup end of the handle of the Big Dipper. The most distant galaxy in the image is extremely faint red galaxy in the circle at the end of the yellow arrow. It's over 12 billion light years away. It's 6 trillion miles to the light year. The image was assembled from 342 separate exposures taken with the Wide Field and Planetary Camera 2 for 10 consecutive days between December 18th and 28th, 1995. This is another image of that. This is the area of the sky where that image was taken, the Big Dipper in the constellation of Ursa Major. I was honored to speak twice at Trinity College in Dublin, Ireland. The first I heard of a telescope called the Leviathan, located at Burr Castle in County Offaly in Central Ireland. My father and I were then invited to visit and tour Burr Castle to see the restored telescope. When we visited Burr, we learned how astronomy with large telescopes really took a giant leap forward with Lord Ross's, the third Earl of Ross's construction of a 2-meter telescope in 1845, and how it retained the title of the largest telescope in the world for 75 years. This was the Irish astronomer and telescope builder, the third Earl of Ross. This is Burr Castle in County Offaly. The rose bush in the picture is 400 years old. This is the Burr telescope. Lord Ross's main aim was to build a telescope at least as large as those of the famous observer and telescope maker William Herschel in England. As Herschel left no details on how to produce and grind large mirrors, Lord Ross had to rediscover all of this for himself. It was not until 1839 that he made a 3-inch mirror, and this was followed by a succession of mirrors 15 inches, 24 inches, then 36 inches. Finally, in 1842, he felt confident enough to start work on a 72-inch masterpiece. He had to cast the mirror 5 times before he was successful. It took 9 months to cool it down in a stone oven fired with peat from a local bog. This is a sketch of the M51 galaxy as observed and drawn by Lord Ross at the eyepiece of the Leviathan, almost 50 feet off the ground in 1845. When we visited Burr Castle the other day, they showed us the lantern that they used while they were sketching these objects, and it has an amber-colored glass lens in it. It was an oil lamp. It was really quite amazing that they recovered that artifact. This is the same galaxy observed by Lord Ross. This is the Whirlpool Galaxy. This image was taken by Tony and Daphne Hollis. They're famous astrophotographers. And this is the same galaxy image by Hubble. It's a 204 megabyte image, and the amount of detail in this image is just astounding. As NGC 51 drifts by, the galaxy on the right, its gravitational muscle pumps up the waves in the Whirlpool's pancake-shaped disk. This graphic shows ripples like ripples in a pond generated when a rock is thrown in the water. When the waves pass through orbiting gas clouds within the disk, they squeeze the gaseous material in the dense clouds along the arm's inner edge. As those gas clouds and dust clouds collapse, they create a wake of starbirth, as seen in the bright pink star-forming regions. Some of those pink regions are many, many times the size of the Orion Nebula. Also, Ireland is famous for another astronomer, John Lewis Emil Dreyer. Was a Danish-Irish astronomer. His father was John Christopher Dreyer and his mother Catherine Tettill of Kilmore County, Limerick. He was responsible for the NGC and IC catalogs of several thousand objects, which are still, those catalogs are still used today. This is the Crab Nebula. supernova remnant, also called M1. Sometime in late June 1054 AD, a massive star 6,300 light years away in the constellation of Taurus exhausted its supply of nuclear fuel and underwent gravitational collapse, then exploded in a supernova. The expanding debris of this cosmic explosion gave rise to what's now known as the Crab Nebula. Around the 5th of July, 1054, the supernova was visible in broad daylight, having reached a maximum brightness of about 10 times that of Venus, the brightest astronomical object visible from Earth besides the Sun and the Moon. It remained visible for 23 days and by night for 653 days. The most detailed observational accounts of this spectacular phenomenon are found in Japanese and Chinese records. Curiously, however, only 2 brief reports of supernova are known from medieval Europe. These are the supernova explosions of 1572 and 1604. By Chinese accounts, this supernova was a tremendous celestial display, but the Europeans may not have agreed, or the weather in Europe didn't cooperate, because astronomers have not found any European records of the event. In 1968, astronomers discovered a neutron star called the Crab Pulsar at the center of the nebula. It's among the first pulsars ever discovered and is the fastest rotating and most energetic pulsar formed from a supernova explosion. The optical pulsar is about 15.5 miles in diameter, and the pulsar's beams rotate once every 33 milliseconds, or about 30 times a second. The Crab Pulsar acts as a celestial power station and generates enough power to keep the entire nebula radiating over almost the entire electromagnetic spectrum. Because of the pulsar's power, the nebula is brighter than 75,000 suns. A neutron star's density is 50 trillion times that of lead. A neutron star is so dense that the resulting force of gravity would be so strong that if an object were to fall from just 1 meter high, it would hit the surface of the neutron star, traveling at about 4.3 million miles an hour, or 1,243 miles per second. 1 teaspoon, 5 milliliters of this material would weigh 110 trillion, 231 billion, 131 million, 92,439,000, or 439 pounds.
I like the 0.5 at the end of that.
Oh, yes. Necessary, yeah.
You couldn't give us that figure again.
There was an Indian tribe in New Mexico that also observed the supernova event, the Anasazi, and they made a rather accurate portrayal of it. This is on a cliff face. If you were to stand with your back where the sun image, against where the sun image is at, and look up, there's the position of the moon, the supernova event, and it actually is quite accurate. The hand in the picture relates that this had a religious significance to them. This is Chaco Canyon. The Penasco Blanco ruins are in the foreground, and the pictograph that I just showed you is in the distance along the canyon wall. It's about 1,500 feet along this wall right here, back along the edge. This is an image of Saturn in the Crab Nebula. On the night of the 4th and 5th of January 2003, there was a rare conjunction of Saturn and the M1, where the orbital motion of Saturn made it appear to pass in front of M1. This image was taken by my friend Philip Perkins in England and shows the position of Saturn at about 1:52 Universal Time on the 5th of January from Wiltshire, England. This is the famous Pleiades star cluster of 7 sisters. It's 425 light years away in the constellation of Taurus the Bull. The word Subaru in Japanese, for which we have lots of those cars, and their little symbol on the back is the cluster of stars. This image was taken by amateur Stephen Canastra. The Milky Way galaxy is a spectacular panorama. This image was constructed by Axel Mellinger from 51 wide-angle photographs. It took 3 years to produce, showing how the whole sky appears at visual wavelengths. The view is dominated by light from stars, which are confined mainly in a horizontal band, making the plane of our Milky Way galaxy, and crisscrossed by foreground clouds of dust. This is a giant elliptical galaxy, NGC 1316. It's located in the Fornax cluster seen in the southern constellation of the name, the Oven. A galaxy of special interest in connection with current attempts to establish an accurate distance scale of the universe. This is Betelgeuse in the constellation of Orion. This is the first direct picture of the surface of a star other than our sun. This was taken by the Hubble Space Telescope in 1995. The atmosphere of Betelgeuse reveals some unexpected features, including a bright hot spot visible below the center. It's about 600 light years distance, easily recognizable by its brightness and reddish color in the constellation of Orion. While it's cooler than the sun, it's much more massive and over 1,000 times larger. If it was placed at the center of our solar system, it would extend well past the orbit of Jupiter. Betelgeuse is nearing the end of its life and will become supernova in perhaps a few tens of millions of years. We can see the size of the star. This represents the size of Earth's orbit, and this is the size of Jupiter's orbit. So, very, very large star. This is Proxima Centauri. It's the closest star at 4.22 light years away. The star is so faint that it was only discovered in 1915 and only visible through a telescope. It would take 76,000 years traveling at the speed of the Voyager spacecraft to reach a star, or about 2,400 generations of humans. This is Mycen 18, or the Hourglass Nebula. Sometimes people call it the Eye of God. The Hourglass Nebula was featured on the cover of the April 1997 issue of National Geographic. The nebula's unique appearance led the magazine editors to comment, "Astronomers looked 8,000 light years into the cosmos with the Hubble Space Telescope, and it seemed that the Eye of God was staring right back." It's a young planetary nebula situated in the southern constellation of Musca, the Fly, about 8,000 light years away from Earth. It was discovered by Annie Jump Cannon and Margaret W. Mayall during their work on an extended Henry Draper's Sky Catalog of Stars. Structurally, it's one of the most complex nebula known, with high-resolution space telescope observations revealing remarkable structures such as knots, jets, and sinewy arc-like features. This was discovered by William Herschel on February 15, 1786, and was the first planetary nebula whose spectrum was investigated by the English amateur astronomer William Huggins in 1864. I neglected to mention this is the Cat's Eye Nebula, also known as NGC 6543. It's in the constellation of Draco. This is the Pillars of Creation, or the Eagle Nebula. This image was taken by Jeff Hester and Paul Scowen in 1995 using the Hubble Space Telescope, and greatly improved scientific understanding of processes inside the nebula. This famous photograph, known as the Pillars of Creation, depicts a large region of star formation. The column on the left is about 3.5 light years in length. This is W5 Cassiopeia. This is a giant star-forming region, 200 light years across and about 6,500 light years away. The sculpted clouds of cold gas and dust seem to form fantastic shapes in this impressive mosaic of infrared images from the Spitzer Space Telescope. This is NGC 891. It's a fine edge-on spiral galaxy with a dark dust lane along its equator. It's another discovery of Carolyn Herschel, who also found it in August of 1783, before assisting her brother William Herschel in his great Deep Sky survey starting in 1782. Carolyn herself was an avid astronomical observer, and the discoverers of comets. She originally found 8 of them and many other deep sky objects. And Carolyn and William lived in Bath, England. This is the Horsehead Nebula, imaged by Philip Perkins. Earthly dust may seem insignificant and trivial, but the cosmic kind of dust is an all-important constituent of matter throughout the universe and is essential to star-making processes. The famous Horsehead Nebula represents a dark cloud of dust and non-luminous gas which obscures and silhouettes the emitted light of IC-434 behind it. IC-434 in turn receives its energy from the bright star Sigma Orionis. Protruding from its parental cloud, the Horsehead is really a dynamic structure and a fascinating laboratory of complex physics. This image of the Horsehead was taken by amateur Jay Gabani. Very, very beautiful image. This is the Bubble Nebula imaged by Russell Croman. This is an expanding shell of gas and dust thrown off by a massive hot blue star. It's pushed by stellar wind in the central massive star, BD 602522. This is the Trifid Nebula, also known as M20, a photogenic study in cosmic contrast. It lies about 5,000 light years away toward the nebula-rich constellation Sagittarius. Star-forming region in the plane of our galaxy, the Trifid alone illustrates three basic types of astronomical nebula. Red emission nebula, dominated by light from hydrogen atoms, blue reflection nebula produced by dust reflecting the starlight, and dark absorption nebula where dense dust clouds appear to silhouette. This is the Arches cluster. It's the densest known star cluster in the Milky Way and is located about 100 light years away from the center of our galaxy in the constellation of Sagittarius. The radius of the cluster is approximately 1 light year. It contains about 1,000 young, very hot stars that are many times more massive and larger than our sun. The jewel of the southern sky, the Great Carina Nebula, is known as NGC 3372, spans over 300 light years, one of our galaxy's largest star-forming regions. Like the smaller, more northerly Great Orion Nebula, the Carina Nebula is easily visible to the unaided eye, though at a distance of 7,500 light years, it is some 5 times farther away. This stunning telescopic view reveals remarkable details in the region's glowing filaments of interstellar gas and dust, dark cosmic dust clouds. This is NGC 4945, a galaxy 6 times farther away than the Andromeda Galaxy at 17 million light years. It's located in the constellation of Centaurus. That star that was circled there is a supernova, supernova SN 2005 AF. This is the Helix Nebula in Aquarius. The Helix is the closest example to Earth of a planetary nebula created in the end of the life of a sun-like star. The outer gases of the star were expelled into space. They appear from our vantage point as if we were looking down a helix. The central remnant star core, destined to become a white dwarf, glows in light so energetic that its radiation that it causes previously expelled gas to fluoresce. It's about 650 light years away in the constellation of Aquarius and spans about 2.5 light years. This is a close-up of cometary knots in the Helix Nebula. Each one of these knots is larger than our solar system. So, incredibly large structure. It's also another close-up. This is NGC 1365 in the constellation of Fornax, Latin for furnace. It's a barred spiral galaxy of about 56 million light years away. The spiral arms extend and curve north and south from the ends of the east-west bar and form an almost ring-like Z-shaped halo. This is M81, also known as NGC 3031 or Bode's galaxy. It's about 12 million light years away in the constellation of Ursa Major. It's one of the most striking examples of the Grand Design galaxy. This is a galaxy called Centaurus A. The shells around Centaurus A indicate an ongoing collision with smaller galaxy. The shells themselves aren't considered particularly unusual. However, an unexpected attribute is the abundance of gas which should become separated from the stars during the collision. This is a natural color image. This faint blue arc right there is 5,000 light years long. This is a jet from the galaxy M87, the giant elliptical galaxy. Streaming out like a cosmic searchlight, it's one of nature's most amazing phenomena. A black hole powered jet of electrons and other subatomic particles traveling at nearly the speed of light. In this NASA Hubble Space Telescope image, the blue jet contrasts with the yellow glow from the combined light of billions of unseen stars, and the yellow point-like spots you see are globular clusters, not individual stars. Those are globular clusters. This is an artist's rendition of a Phoebe black hole. This is a 4-color image of the sun. It was taken with the EIT instrument on board the space-based SOHO Observatory. This tantalizing picture is false colored composite of 3 images made in extreme ultraviolet. Each individual image highlights a different temperature regime in the upper solar atmosphere and was assigned a specific color: red at 2 million degrees, green at 1.5 million degrees, and blue at 1 million degrees centigrade. This is the Ring Nebula. It's the most famous planetary nebula. It's 2,300 light years away in the constellation of Lyra. The central star is very, very hot, about 216,000 degrees centigrade. This is 2 galaxies interacting in the constellation of Canis Major. The larger galaxy, NGC 2207 on the left, is producing strong tidal forces distorting the galaxy on the right, IC 2163, which is throwing out streamers of stars toward the right side of the image that are 100,000 light years long. This is NGC 6751, a striking planetary nebula in the constellation of Aquila, the Eagle. The shape and colors of the nebula are affected by the temperature and radiation from the star at the center. The central star's surface temperature measures an astounding 140,000 degrees Celsius, or 250,000 degrees centigrade. This is NGC 1850. It's not in the Milky Way. It's about 168,000 light years distant, located near the outskirts of the central bar structure in our neighboring galaxy, the Large Magellanic Cloud. This is M42, the Orion Nebula. It's about 1,500 light years away. It's the nearest star-forming region to Earth. More than 3,000 stars of various sizes appear in this image. Some of them have never been seen in visible light. The stars reside in a dramatic dust and gas landscape. It's a picture book of star formation. This is M42 in mapped color. This was taken by an amateur, Russell Croman. This is called the Golden Wall, or NGC 281. This also is taken by the amateur Russell Croman. This is the planetary nebula MZ3, or the Ant Nebula. Why isn't this ant a big sphere? Planetary nebula MZ3 is being cast off of a star similar to our sun that's surely round. Why then would the gas that's streaming away create an ant-like shaped nebula that's distinctly not round? Clues might include the 2,250,000 mile per hour velocity of the expelled gas, the light-year-long length of the structure, and the magnetism of the star visible above the nebula's center. Another possible answer is that it's hiding a second dimmer star that orbits close to the bright star, causing the pinching in the center. This is an object called Hoag's object. This nearly perfect ring of young hot blue stars circle the older yellow nucleus of the galaxy about 600 million light years away in the constellation of Serpens. The diameter of the galaxy is slightly larger than the Milky Way. The interesting thing, I think, in this picture is there's a second ring galaxy in the background there. They're quite rare, and then to have those in the same field are amazing. This is the antenna galaxies, NGC 4038 and NGC 4039, taken by an amateur astronomer named Daniel Versace. Some 60 million light years away in the southern constellation of Corvus, the 2 large galaxies have collided. Stars in the 2 galaxies don't really collide in the course of the ponderous billion-year or so long event. Instead, the large clouds of molecular gas and dust do trigger furious episodes of star formation. Spanning about 500,000 light years, this stunning view reveals new star clusters and matter flown far from the scene in an accident by gravitational tidal forces. Of course, the visual appearance of the far-flung arcing structures gives the galaxy its popular name, antenna. Recorded in the steep image of the region at the tip of the upper arc is a tidal dwarf galaxy, NGC 4038, formed in the cosmic debris. To give you some idea of the scale of some of the objects and distances in space, let's take an imaginary trip to the nearest star, Proxima Centauri, which resides 4.22 light years away. Prior to the Helios 2 spacecraft, the Voyager 1 spacecraft held the previous record for the fastest spacecraft and traveled at about 38,000 miles an hour. If Voyager 1 was traveling to the red dwarf star Proxima Centauri, how long would it take to get there? At a constant velocity of 38,000 miles an hour, it would take 76,000 years, or over 2,400 generations, to travel that distance. What if we could attain this record-breaking speed of Helios 2's close approach to the Sun, traveling at a constant speed of 241,401 kilometers an hour? It would take 19,000 years, or about 600 generations, to travel that distance. To travel the length of the distance spanning these two antenna galaxies, a distance of 500,000 light years, it would take 9,012,256,669 years, or just under 2/3 the age of the entire universe. If we take 30 years to be an average human generation, it would still take 300,408,556 generations of humans to make the trip. Helios 2 would make the trip in a mere 2,209,302,325 years, or 73,643,411 generations of humans to make the trip. Whoops, don't forget we have to add another 60 million light years to travel just to begin our journey across the galaxies. It only adds another 9,743,684,610,526,316 years to our travel time. So, oh well. The point of all this is, if interstellar travel will probably never be practical because physics won't allow travel faster than the speed of light. Sorry, all you Star Trek fans. This is M81, also known as NGC 3031, or Bode's galaxy. M81 and M82. The red light is emitted in the so-called H-alpha line at a wavelength of 6,563 angstroms. This is NGC 6946, taken by an amateur, Robert Gendler. This is 10 million light years away in the constellation of Cepheus. At least 6 supernovae have been discovered in this galaxy. This is the Veil Nebula, NGC 6992. It's only showing a beautiful portion of the veil, the shattered remains of a supernova that exploded 5,000 years ago, or 1,400 light years away in the constellation of Cygnus the Swan. This is another image of the Carina Nebula, large bright nebula that surrounds several open clusters of stars, Eta Carinae and HD 931-129A. This is the center of the Carina. This is also taken by an amateur, Gavain. This is BHR-71. This is an unusual type of interstellar gas cloud known as a Bopp globule. Bopp globules, named after astronomer Bart Bopp, who studied them extensively, are small dark clouds made of gas and dust that are typically condensing to form a star of stars. There's actually a binary star being born up in here, and if you look carefully, you can see kind of a bubble of gas down here. The shock wave is pushing away. The other side's obscured in the globule itself. Two billion light years away, galaxy cluster Abel 1689 is one of the most massive objects in the universe, bending the light from individual galaxies which lie behind the cluster. The galaxy field exhibits a phenomenon predicted by Albert Einstein known as gravitational lensing. In general relativity, the presence of matter, energy, density can curve space-time, and the path of light can be deflected as a result. Most of the mass required to explain this scale of cosmic lensing is comprised mostly of dark matter. This is M8, or the Lagoon Nebula, imaged by Russell Croman in mapped color. This image of Halley's Comet by Jerry Rodriguez is one of the most famous comets of all time. It has an orbital period of 76 years. During the 1985-1986 apparition of Halley's Comet, the Giotto spacecraft came within 605 kilometers of the comet and took the first ever images of the comet's nucleus. Edmund Halley correctly predicted in 1705 that the comet that had appeared over London in 1682 would reappear again in 1759, and that it was also the same comet that appeared in the years 1607 and 1531. When it did in fact reappear in 1759 as he predicted, it was named after Halley, who unfortunately did not live long enough to see his prediction come true. Working backwards in time, it was discovered that Halley's Comet had been appearing in historical records for thousands of years. The earliest recorded observation was in 239 BC by Chinese astronomers. During the comet's 29th recorded apparition in 1910, the poisonous gas cyanogen was discovered in the tail, and when it was predicted and published by the New York Times that the Earth would pass through the tail, a panic ensued. In the New York Times report on the comet on February 8, 1910, the headline read, "Deadly cyanogen found in comet's tail." Unfortunately, many people committed suicide, and there were shysters out there selling comet insurance. He quoted them saying, "Cyanogen is a very deadly poison. A grain of its potassium salt touched to the tongue being sufficient to cause instant death. If Earth passes through the tail, as astronomers predict, the cyanogen gas will impregnate the atmosphere and snuff out all life on the planet." Halley's actually passed 13 million miles away from the Earth's orbit, but because of the close approach, caused the tail to grow to amazing length. The location of the comet relative to the Earth's orbit in the 1985-86 appearance related to a relatively disappointing view for the public. This is the Giotto spacecraft. It was named for the Italian painter Giotto di Bondone, who painted the October 1301 appearance, also called an apparition of Halley's Comet, in a painting called the Adoration of the Magi. You can see it here in the top of the image. Comets originate primarily from the Oort cloud, a belt of protostellar material that surrounds our solar system and stretches nearly halfway to Alpha Proxima, the nearest star. Comets are basically big dirty snowballs composed of various ices such as carbon dioxide, carbon monoxide, methane, ammonia, water ice, and dust interspersed with various other elements and compounds. Occasionally a passing star or one of the larger planets perturbs an orbit of one of these balls of debris, pushing it into the solar system towards the sun in a long elliptical orbit. As the comet approaches the sun, the nucleus of the comet heats, and at about 3 to 3.5 astronomical units, which is the Earth-Sun distance, 93 million miles, gas and dust begins to boil off. As the various ices melt, because space is so cold, they bypass the liquid phase and sublimate and go directly into a gas, just like ice cubes if you leave them in the freezer too long. Then as the ices melt, the solar wind pushes the gas and dust behind the nucleus to form the tail. This creates a bright coma around the head and tail of the dust and ionized gases, stretching sometimes for hundreds of thousands, millions of miles. Depending upon the size of the orbit and whether or not it originated in the solar system or in the Oort cloud, a comet can return in several years or in many thousands of years. This is the nucleus of Halley's Comet. It measures about 8 miles in length and 5.5 miles in width. In contrast, most comets are about 1/2 mile to 1.5 miles in diameter. Comet Hale-Bopp's nucleus was extraordinarily large and measured about 52 miles in diameter. Halley's Comet has an orbital period of 76 years. Notice the jets spraying to the left. These are then pushed back by the solar wind to form the tail. This is an image during a solar eclipse, which gives you an idea of how the solar wind comes off the sun. This is what pushes the particles sublimating off a comet back to form the tail. The solar wind has a speed that varies between 1 and 2 million miles per hour. This is an artist's conception of Earth's magnetosphere. As the charged particles from the sun strike the magnetosphere, some of them are funneled down the magnetic field lines at the poles, and that's what gives us the Aurora Borealis and the Aurora Australis. This is a Japanese artist named Shizumi Numazawa's conception of the nucleus of Comet Hale-Bopp. You can see the particles sublimating off the nucleus in jets, which are then blown back to form the comet's tail. Saturday, the 22nd of July, 1995, my friend Jim Stevens called to tell me that the telescope that he had been working on for the past year was finished, and he asked if I would like to go out observing with him that night to check it out. I said yes. However, this is Arizona's rainy season, or what we call the monsoon season, and it had been raining for weeks. When he called me in the morning, I was still in bed, and I said, "What, are we going to use a Hubble filter to look through the clouds?" Well, he said, "No, look outside." I looked outside, it was a perfectly clear day. There wasn't a single cloud in the sky, and the rain had washed all the dust out, and the sky had settled down. It was an absolutely brilliant day. I planned on leaving about 2 that afternoon to go where we would be observing that evening, about 95 miles southwest of Phoenix, out in the desert, to get away from the city light pollution. When I went to start my car, I decided it didn't want to go. Maybe it was carburetor problems. So I called my dad up and I said, "Dad, can I borrow your car? Jim's got his telescope done, and I really want to go observing with him." So he said yes, but since I got a late start, and by the time I got over and picked up my dad's car and transferred all my gear into his car, I got down to the observing site late. Now, the wonderful thing about my dad's car, it was a Cadillac, and you cannot shut the headlights off. So guess who drove onto an observing site with his bright white headlights? I said when the gunfire and the cursing died down, I had the guts to cover up the overhead light and open the car door and sneak out with my tail between my legs and make my way through the dark because I could hear Jim's voice, and found out where he was observing. Needless to say, I was quite embarrassed. We started working in the northern sky and gradually worked our way down into the southern sky, and a little bit before 11 o'clock, we were looking in an area of the sky. This is called the Sagittarius star cloud. These are true colors. It's located in a narrow dust-free region showing a spectacular treasure chest of the sky's finest gems. Some of these are the oldest stars in the Milky Way galaxy. This is the area of the giant red star Antares and Rho Ophiuchi. Why is the sky near Antares and Rho Ophiuchi so colorful? The colors result from a mixture of objects and processes. The blue reflection nebulas, the red emission nebulas, and the yellow reflection nebula around the giant star Antares. This is the area of the sky where we were observing when I discovered the comet. I was looking at the Lagoon and Trifid Nebula, located in the constellation of Sagittarius, about 5,000 light years away. We decided that we were going to observe some of the globular clusters located in Sagittarius. And globular clusters, of course, being tightly packed balls of stars. They are some of the oldest objects in the galaxy and were formed at the very beginning of the formation of the galaxy. This is a fine example of a globular cluster. This is M80. It's one of about 150 globular clusters in the Milky Way. This is 32,600 light years away. One of the interesting things in M80 was the discovery of stars called blue stragglers. These are stars that actually they believe were formed from collisions. It had been thought that collisions between stars were relatively rare, but now they believe that this happens more often than they had previously thought. This is a globular cluster M10. It was imaged by amateur astronomer Daniel Versace. This is 47 Tucana, or affectionately known by amateur astronomers as 47 Tuc. It's 16,700 light years away from Earth. This is Omega Centauri. There's more than 10 million stars in its cluster. It's 15,000 light years away from Earth. I think that a Japanese amateur astronomer named Keiji Tagami summed up the attitude of amateur astronomers the best when he first observed Omega Centauri through a telescope. He said, "Peeping into the telescope, which became almost level, I received the impression in which the skin on the living body bubbles. Signs that the countless faint stars crowded into view are visible with a cubic effect. Thank you, really." This is M70, the last globular cluster we were going to observe in Sagittarius. It's 29,400 light years away, receding from us about 500,000 miles an hour. As I was watching it drift slowly across, Jim took a quick look in the eyepiece and then said he was going to go over to the car and look at the atlas to see what else he wanted to look at. As I was watching it drift slowly across the field of view, I noticed a small fuzzy object sitting off to the side. it was this little fuzzy object right here. Of course, this is a photographic image, so it appears much brighter than it actually was. It was about the size of a full stop at the end of a sentence, and it was at 11th magnitude. So I called to Jim and I said, Jim, do you know of anything else up here by M70? He said, no, what do you got? And I said, oh, I got a little fuzzy. So he walked back over and he took a look. He said, no, I don't know what that is. And we both walked over and got out the atlases, and we were looking at Will Terry-owned Skyless 2000, and it wasn't in there. And then we got out Uranometria, with a 2-volume set with 332,556 objects in there, and it wasn't in there. So Jim says, I think you got a comet. I said, well, we're going to have to watch it for a while and see if it moves against the background field stars. So we began watching it, and sure enough, a half hour passed, and Jim says, I think it's moved. Well, I've heard horror stories of people reporting things to the Central Bureau for Astronomical Telegrams in Cambridge, Massachusetts. They're the worldwide clearinghouse for astronomical discoveries, and over 99% of the reports they get are false alarms. I didn't want to be on that list, so I said, well, I want to watch it for a little while longer to make sure. So there were 4 little stars sitting off kind of in a crescent shape to the side, and I eyeballed the distance between the 4 little stars and this little fuzzy dot, and watched it for another half an hour, and the distance opened up a little bit between those stars and the little fuzzy dot. So I got out my cell phone and I was going to call an astronomer at the Lowell Observatory in Flagstaff named Brian Skiff and see if I could get him to put a big scope on it to confirm it before I reported it, because I didn't want to fool myself. But, I called the operator and she connected me, and it ended up I got his answering machine and he was in Europe at the time, so that didn't help. And I went to call the operator back. I decided, well, I was just going to go ahead and take a chance and report it, and my cell phone quit.
Oh.
So I jumped in my car and drove down the road to a truck stop about 20 miles away and called Western Union to send a telegram to report it, but they couldn't help me because I didn't have an address for the Central Bureau with me. I hadn't planned on making a discovery. So I jumped back in my car again and drove the other 70 miles on home. I think I set a new land speed record. And, I found the comet at 11 o'clock at night, and by now it's 20 to 3 in the morning when I get home. I rummage around through my books, find the address for the Central Bureau, call an operator in Cambridge, Massachusetts, and she gives me a telephone number for the Central Bureau. Unfortunately, it was for their visitor center, which was open from 8 to 4, thank you very much. So that didn't help, but at least I had an address, so I called Western Union back and fired off a telegram giving the location and the direction of movement and so on. And went and piled into bed. 25 after 8 the following morning, the telephone rang, and voice on the other. I said I jumped out of bed. I don't even think my feet hit the floor until I was outside the bedroom door. Forgot all about the telephone in the bedroom. Ran in the kitchen and grabbed it. And the voice on the other end of the line said, "This is Dan Green from the Harvard-Smithsonian Astrophysical Observatory. Is this Thomas Bopp?" I said, "Yes." He said, "Did you report a comet?" I said, "Yes." He said, "Well, congratulations, you got a new comet." And then I invented a new comet dance around the kitchen floor. They called me back 2 days later, and they said that they had 58 observations of the comet, and that it had been here once. They were able to determine that it had been here at least once before, and that it was going to come into the inner solar system. Well, I spoke to Brian Marsden, who was the director of the Central Bureau at the time, and I said, "Dr. Marsden," I said, "if I could see this through an amateur scope," they told me also that it was 7.16 astronomical units out beyond the orbit of Jupiter. I said, "If it's so far distant and I can see that at 11th magnitude at that distance, this thing must be big." He said, "Tom, it's a monster." At the end of the week, they had 258 observations of the comet, and they were able to determine a very precise orbit. They were able to tell that it was going to reach perihelion April 1st, 1997, so it was going to take a year and a half for it to come in. But because the comet was bright at such an immense distance, astronomers speculated that the comet Hale-Bopp may be similar to another comet that was bright when it was discovered. In 1973, comet Kohoutek was discovered and brightened rapidly, raising expectations that this would be a bright, spectacular comet, perhaps the comet of the century. However, the comet only reached approximately 4th magnitude in January of 1974, which is only 2 magnitudes brighter than the faintest star that can be seen with the naked eye, and was overall a disappointing show for the public. The comet was still very interesting to professional astronomers who determined that this comet was making its first trip in from the Oort cloud. This is Comet Hale-Bopp 1 week after the discovery. This is on the 2nd of August 1995, imaged by David Tholen of the University of Hawaii. The coma, the cloud of gas and dust around it, was 2.5 million miles across. On the 18th of August, the Hubble imaged the Hale-Bopp for the first